So question 7, in a wind tunnel, the pressure on the top surface of the model airplane wing is 8.6 times 10 raised to 4 newtons per meter squared, and the pressure on the bottom surface is 8.8 times 10 to the 4 newton per meter squared. So in a wind tunnel, the top surface of a model airplane wing, so this is the wing of the airplane, so it's a very crude diagram, right? And looks more like a satellite. And the pressure on the top surface of the model airplane is 8.6 times 10 to the 4 Newton per meter squared. The pressure on the bottom, so from the bottom it's experiencing an 8.8 times 10 to the 4. So you can see that the pressure from the bottom is greater than the pressure from the top, so there's obviously a lift upwards. If the area of the top and the bottom surface of each wing, so the area of the top and the bottom surface is 1.8 meters squared, what is the total lift on the model airplane? So the total lift will be a sum of the individual lifts created by each of these, created by the forces on each of the wings. So you'd have to pretty much do the calculation twice or just sum them up. So the total lift is going to be, what is lift? Lift is the force from this minus the force from this. So I'm going to call it force. I'm going to call this force 1, force 2. So force due to this pressure minus force due to that pressure. Force 1 minus force 2. And what's force 1 minus force 2? Force 1 minus force 2 is pressure 1 times area minus pressure 2 times area, right? And what is pressure 1? Pressure 1 is 8.8 times 10 to the 4. What is area? 1.8 minus what's pressure 2? 8.6 times 10 to the 4. What's area? 1.8. Now that's just the lift on this wing, so I'll have to do twice that because I need the lift on this wing too. And this should give me 2 times 0.3600 times 10 to the 4 newtons, which is 7,200 newtons, or 7.2 times 10 to the 3 newtons. I hope that makes sense. So the idea here is lift is just like the last question. Lift is force upward minus force downward, or force downward minus force upward, depending on which is greater. We know that the pressure from the bottom is greater, so it's force 1 minus force 2. We put the formulas. Force 1 is pressure times area, force 2 is pressure times area. Plug in all the values, we get the total lift. We do it twice that because there are 2 wings. Next question. Okay, I'm just going to continue over here. What is question 8? Question 8 is, how much power is theoretically available from a mass of 1000 kgs per second of water when it falls a vertical distance of 110 meters? So there's water, it falls 110 meters. What is, how much power? So power is at work over time, or the energy over time, and the energy here we're talking about is mgh, and potential energy due to height, or gravitational potential energy. And that's going to be mass, so we're talking about 1000 kgs per second. G is 9.8, and height is 110 meters. Divided by time again is 1 second. So that's an assumption we're making. When we do the math, we should get 10 AD kilowatts. That's how much energy you're expending per second, which is also called power. Hope that makes sense. And I'm going to wind up here. I'm going to attach the